So turn and talk with your team. Can you find the difference in the number of blocks between each pair? And then you're going to write that difference. So between 1 and 3, what's your difference? And then we're going to use that to write an equation. Turn and talk with your group. You're doing this with your group. What's the difference? Can you write an equation? What was the common difference you guys found? 2. Yeah, this is going up by 2. This is going up by 2. This is going up by 2. When I start to write the equation, what is that for my equation? Do you remember what it's called? The plus 2. What is it? Slope. What's my y-intercept? What are we starting with? 1 plus 1. And if you didn't know already, what is this pattern called? What type of function is this? That's the last question. It's linear. It's linear. Fantastic. Number 2, we've got another pattern. We've got another pattern. So in number 2, I want you to start by making a sequence. Can you count the blocks? Can you make the numbers, the sequence? Then find the difference. Then try to figure out the difference between the differences. Turn and talk with your team. You're doing number 2 now. Number 2. Here we go. Well, my first difference, it goes 2, then 3, then 4. There's a pattern, but it's not a common difference like we had in the first example. So now you need to find the difference between the differences. So between 2 and 3 and 3 and 4, what's it doing? Plus 1. Good. And labeled, this is our second difference. This is our second difference. This does have a common difference this time. It's plus 1. So in our first pattern, I had to go one difference or one stage below my sequence, and I could find our slope. But for this example, I had to go 2 steps to find my common difference. So for this equation, it's going to be a little trickier. So I'm going to relate it back to area. So for part D, did you guys try to write an equation yet or no? Did anyone try? No? That's okay. I'm going to relate it back to area. Okay? For D, write a pattern where x is the figure number and y is the number dots or cubes used. How is this type of equation different than number 1? So what's happening is we've got a side length of 1, and then what happened to this side length? Plus 1. So I could say it did x plus 1. Okay? So we've got 1. We're adding 1. What else? How else could I describe the area? I'm okay with us just recognizing that this is going to be a quadratic relationship. And it's kind of weird because it looks like it's a 2 by 2, a 3 by 3, but we are subtracting some of the blocks as we go. So for part D, we'll just say that this is the area of a rectangle, but what's happening is it's being divided by 2. So we've got the area of a rectangle. The area of a rectangle. And it's being divided by 2. So we see that pattern. It's definitely going to be quadratic. For right now, we'll leave it at that. We don't need the equation today. Next page, we've got another figure of blocks. We've got another figure of blocks. So with your group, write out the sequence for the number of blocks. You can't see some of them, but think about a 3D block. Find the difference. Find the second difference. You're going to find the third difference, and then we'll talk about the equation. So with your team, you're going to do A through C. When you get to that third difference, you should notice it's 6. Our third difference is 6. We got a common difference. It took us 3 times. So before we had a linear function, then we had a quadratic, x squared. What do you think this equation is going to look like if it takes to get a third difference to find our common difference? We had an x. We had an x squared. What do you think this function is going to look like? X cubed. Sweet. X cubed. So we finally get to part D. We finally get to part D, and the common difference is 6. It takes to the third difference to find the common difference of 6. So if we were to write an equation, it's going to be y equals x cubed. Because we were dealing with a cube. We had our length, our width, and our height there. And they were all the same. That second block was a 2 by 2 by 2 to get 8. The third block was a 3 by 3 by 3 to get 27, and so on. How is this type of equation different from the first and second ones? I think we already summarized this. This one has an x cubed. In number 1, we had a linear equation. In number 2, we had a quadratic equation. How do you think the differences in a sequence are related to the type of function of the sequence? This is the big question here. So every time we have to go to another set of differences, what do you think happens to the x or the exponent? We talked about exponents yesterday. What, Vinny? Yeah. Good. So every time you have to find another difference, the exponent on x goes up. The exponent on x goes up. And we practiced with exponents yesterday. Okay, that's why we did exponents yesterday. Okay? So really we're starting to look at polynomials. Polynomials have many terms, and we're going to look at our quick notes and define this next. We're going to look at some tables and identify from the changes in the patterns, can we figure out what degree polynomial will have? Okay? Quick notes. Polynomials. What is a polynomial? It means many terms. Poly means many. Nomial in math is going to mean terms. Okay? So, in our lesson, we talked about common differences. Common differences. And common differences is when you get to the same difference, like slope. So we're going to find the differences in the outputs, or the sequence. Okay? Again, the number of differences it takes to get to a common or a constant difference is the degree of the polynomial. So that's what we really looked at in our lesson. Because in our lesson, we had a linear, we had an x squared, and then we had an x cubed. So that'll get us into what is a degree of a polynomial? The degree of a polynomial. Degree. You might be thinking back to geometry. Degrees, are we doing angles again? No, we're not doing angles. A degree of a polynomial is the highest exponent? The largest exponent. So, for example, here's a polynomial. 3x to the fourth plus 2x cubed plus minus 7x minus 12. That's a polynomial because 3x to the fourth has the highest exponent. We would say the degree of this polynomial is 4. The degree would be a fourth. It would follow a fourth pattern. Okay, and we'll start using Desmos here too soon, but not today. Today we're just trying to introduce the basics of a polynomial. Great. Here are some non-examples of polynomials. You ready? Non-examples. If you have a fraction in the exponent, that is not a polynomial. If you have a negative degree in the exponent, that is not a polynomial. If you have division, that is not a polynomial. Or if you have maybe a number to the power of x, that's not a polynomial, that's an exponential function. So these things are not polynomials, okay? And we're going to do the check for understanding together. We're going to see how we're doing with this. A. A, is that a polynomial? Yes. Sure is. What's the highest degree? 6. So this is a polynomial. They tricked you. They put it in a different order. The highest degree is 6. Okay, B, we have to use our rules of exponents from yesterday. X squared over x cubed. How do I simplify that? From yesterday. Yeah, x to the 2 minus 3, so it becomes negative, or I could just leave it in the bottom. Is this a polynomial? No, not a polynomial, but we used our rules of exponents from yesterday. How about 2 to the x? Is that a polynomial? No, that's an exponential function. We did that last semester. 32, is that a polynomial? What do you think? Can I say y equals 32? Will it graph something for me? It is. It is a polynomial, yes. The degree is 0. The degree is 0. It'll graph a horizontal line. Remember, horizontal and vertical lines are still equations. Okay, let's do the first table together. We're going to figure out the degree of the polynomial by finding the differences. By finding our differences. So we're going to list out our differences and see how many differences does it take to get to our common one. So from 0 to negative 2, what happened? From 0 to negative 2, what happened? Minus 2. From negative 2 to positive 2. Tony, what happened? Good. Okay. Next, from 2 to 18, what happened? Brayden, what happened? From 2 to 18, what happened? Great. Then from 18 to 52, what happened? Plus 34. Is there a pattern? No, but that's our first difference. Label it. That's your first difference. Now we got to go to a second difference. Between negative 2 and 4, what happened? Between 4 and 16, what happened? Between 16 and 34, 18. Okay, so that's our second difference. We're not at a common difference yet. I hope it's this third one. Looks like it. This goes up 6. This goes up 6. So it took a third difference to get there. So what's the degree of our polynomial? A third degree. I want you to try B. Try B.